I came across one of these bad girls, well, actually two, in a catamaran, and so I've only ever worked on these in the vessel. Well, we've just remanned this one. It was kind of a remand. The boat actually ended up with a lot of water induction in the engine, so we've sort of used what we can and done the right thing and built an engine to suit to do some long hours, but also had budget in mind. So it is a 485 horsepower 671 inline, which is obvious there, and it pulled 500 on the dyno, which you'll see the video when we post it. She's pulling those revs at pulling that horsepower at 2500, so 2700 no load, 2500 full load with 500 horsepower. So very, very impressive. The engine that I used to look after, the engines I used to work after in the catamaran, see about 2,000 hours before they start fretting the liners in the block. So pretty much after 2,000 hours, you need to go to the next size up on liners. They start to overheat the pistons. There's lack of heat transfer into the block, and yeah, so they're quite short-lived for a 671. But questions a lot of you guys asked on YouTube is about, what could she pull, or what horsepower can you get out of it? And it seems a bit low on horsepower. We get some comments on our engines being low on horsepower. The reason for that is that most of our engines that we do are for industrial applications, workboat applications, and they run small injectors and they run low horsepower, and you get the longevity. You can do a lot more than 2,000 hours in a tug application, or in a industrial application, or a drill rig or something like that. They want to see, well, with GMs, want to see 8 to 15, sometimes 20,000 hours, just depending once again on maintenance and work environment and things like that. So, but these, even if you looked after these engines for as good as you can, you're still only going to see that probably 2,500, 3,000 maybe you'll top out at before you got to start looking at doing some internal works on the engine. A couple of little interesting features with this 671. First and most obvious is the saltwater cooled aftercooler, which is there between turbo and blower. Things run up around 26 pound of boost, running big boost. So they run this weird bypass system. Well, it's not weird, but it's just different. Sort of got these butterflies in this housing here, which relieves the air pressure on the downstream side of the blower and puts it back into the upstream side to just unload the blower a little bit, especially at high boost applications. This blower will actually generate a lot of heat if it's not unloaded. So a little bit like your traditional bypass blowers, except this runs a lot bigger valves. So it's designed for high boost applications where the blower actually gets more efficient with higher boost. It'll produce more boost into the airbox as you increase the boost from the turbo. So you don't really want to do that. It generates a lot of heat. You have blower seizures and things like that. So they run this dual butterfly setup, which you probably have to go onto the internet to actually see that, because obviously we've got it on right now, so you can't sort of see those butterflies. They sort of sit down under there. And then another little feature of these engines is they run an aftercooler after the blower as well. So on the other side of that blower in the airbox, they'll run another aftercooler again. So these are heavily reliant on cold air to generate that sort of horsepower. Obviously they've got big injectors. They run different compression pistons in them as well, a little bit lower. So they once they have any sort of exhaust leak in the engine room and they start to clog up that aftercooler and the intercooler, you start to generate excess heat in the airboxes, which shortens the life of them. So you've got to make sure that you keep the maintenance up on these things because of the work that they're capable of doing. And even if you run them at light loads, you still can't block those aftercoolers up. So that's the thing about most 671s, don't run any aftercoolers. They just run straight out of turbo. If you have a turbo 671, they'll run turbo straight out into the air, into the blower, and then into the airboxes. So there's no air for any type of contamination or clogging in the air system, so they tend to stay pretty healthy as far as air feed goes. But on these ones, once again, you're running tiny little fins, only need exhaust leaks, a bit of oil to get in there, they clog up the aftercooler and intercoolers, and they starve air, and even at light loads they'll start having issues. So air intake systems are critical as far as keeping the maintenance goes. So anyway, enjoy the video. You're not going to see many GMs on our dyno that are spinning out to 2700 no load. It's quite impressive. They're extremely smooth at those RPMs, but once again, scary. So when I set the no load on this one, I actually had a rope, ran the rope into the control room and yanked it up, and yeah, we saw 2700 on the money for no load. So that was all good. So alright guys, enjoy the video, and any questions put in the comments. Cheers.